Hello everyone, I am Keval Solanki and presenting my portfolio for the Studio 3 Integrated Construction Practices. This studio integrates the Lean and the BIM principles, giving insights into the practices followed in industry and the application on the field. The project we have selected is High-Speed Rail Terminal Building. These are the list of the deliverables we performed in our Studio 3 project, and the highlighted topics are presented in this portfolio. The scope of our work was limited to second floor and third floor, and the total area considered was 20,000 meters square. As a team member, the individual role played by me was a BIM coordinator and HVAC consultant. Continuing with the HVAC model, as a consultant, this process flow for the entire HVAC model, starting from the 2D schematic PDF drawing, following up to the class resolution process was followed. Here the HVAC system was classified into three system coding as shown by the different color coding. Scope for the HVAC model was taken for the second and third floor for all these elements mentioned in the table. The above image shows the completed HVAC model for this project. Coming to the challenges, one of the major challenges was to place the parallel pipe in such a way that there are no clashes in between the two pipes at every intersection. To solve this problem, various trial and error were done at the different level of both the pipe in very initial stage of the distribution line, and then narrowing it down to that level where further there were zero clashes between both the pipes. So, despite facing all the above challenges, at the end of the day, all the challenges were sorted out. Coming to the clash detection, these three process maps summarize the entire clash detection and the resolution process performed for the project scope for the 6 different disciplines. As shown, total of 30 different clash detection were performed to get the end product as a 6 clash-free models. So this is the clash matrix showing the number of the clash detected for each test between the 6 disciplines, and the different color coding were used to track the progress. Also, for the resolution purpose, we had various meetings in presence of all the stakeholders to identify the grouping as shown under two categories, that is relevant and irrelevant classes. For the class resolution purpose, we conducted various meetings in presence of all the stakeholders to identify the grouping of each classes. Now, taking one example of the process, this chart shows the clash detection and resolution process of structural model, in which we detected 143 clashes between structural and the HVAC model. From this we observed that the ignorable clashes were very few, but the major clashes were found between HVAC pipes and the structural beam of depth 950 mm, which were in total of 30 clashes. So to resolve these 30 clashes at a time, we figured out three possible solutions, in which the first one was to shifting the supply and the return pipe from the red color area where the beam were of 950 mm depth to the greener area of 700 mm depth of beam. Other two solutions were risky and time and cost consuming. So after the discussion with the site personnel, we came to the solution of shifting the HVAC pipe to avoid all the 30 clashes, which costed the amount of 13,470 as per the class quantification, and we revised the HVAC model as shown. Continuing with the 4D and 5D simulation, the process we follow started from the meeting 1, where we prepared the micro schedule in MSP and exported our Revit models into the Synchro Pro. After that, we followed the following step of resource assigning and creating appearance profile of different elements, after which we were able to compare our 4D planned and actual simulation. After that, we reviewed it in meeting 2 and discussed the following points. Later, for the 5D, we imported quantity from the Revit schedule as a planned unit and the actual unit, and we assigned the unit cost of the concrete to each task to finally obtain EVA graph and the 5D simulation. This is the final 4D 5D combined simulation video, where the top part shows the timeline of the project duration. Now our site was closed on 14 September to 30 September, and as you can see, the work was not in progress in actual simulation, with the reason shown above, that it was declared as a micro containment zone. Here the date and week number along with the 5D costing value for both can be visualized as the site progresses. In the right side, we can see the EVA graph analysis, which is increasing as the site work progresses. This helps in understanding the financial status of the project. We also explored the Synchro Pro for the other uses, such as the site layout assessment for the dynamic site layout movement. Second was for the concrete volume heat map, which gives critical area of concreting. And the last one is the weekly and the look ahead report. So as the site work progresses, active task and 1 week look ahead tasks are generated automatically with visualization of the work. So the inference from the 45D simulation was that it gives better visualization of the sequence, and we also explored the comparison between the Navis work and the Synchro for the 45D, and after performing on both, we found that Synchro was more suitable for these processes. We have also explored augmented reality, game simulation, and virtual reality use in a different medium and technology using game engine software. Using this software, it helps in enhancing our model visualization for the quick decision making, and it can also be accessed by all the stakeholders. Further, it also helps in the visualization of the clash detection and the resolution, immersive experience for the project stakeholders, and augmenting real scale model on the actual site condition. This is the video showing the application of the AR and the VR for our studio project. For the virtual reality, the VR setup was done in the mobile view, as you can see in the screen view, where we can rotate and navigate around using the headset such as Google Cardboard, Oculus Rift, HTC Vive, and etc. Second video shows the augmented reality, which we tried for the structural model. So here, when we move our camera to the marker page, which is having QR code, we can visualize the 3D model. We can rotate it, resize it, and move its location, and freeze it. After that, we can move underneath the model to examine the details of the model like beam and the column. This can also be viewed in the 1:1 scale on the actual site condition for checking the alignment of the real elements.